we're here today. We have a new handout today. So I think all of our participants are here when you guys are good to go. Okay. And does my microphone come through okay? Okay. All right. Welcome, everybody. We welcome you to the Atwood Innovation Plaza here at Dixie State University for our Gyro Sensor Clinic. We're so excited you're here today. We're again working with the gyro sensor, which we'll use to control what direction your robot is facing. Okay, it'll help control where your robot is looking, what direction it's facing, so that as you drive, you can be more accurate about where your robot ends up by having a good direction. So you should have come with your robot having a gyro sensor already attached to the robot. Several of you, I went and checked your robots. I think you guys just came in a few minutes ago. Can we check? You've got your gyro sensor, and I'm just checking to make sure that it doesn't wiggle. So you've got it attached with 2 points on there so that it doesn't move. It's important for the gyro sensor to be fixed solid against your robot, so when your robot moves, the gyro sensor moves the same amount. That's how it's going to work. Okay. The way the gyro sensor works is at any given time, the gyro sensor is aware of what direction it's facing. So as your robot starts to turn, the gyro sensor can record what angle you're looking at, and it records an angle from 0, and let's see, if you keep turning, what kind of angle do I reach if I go halfway around a circle? 180, that's correct, okay. And if I go all the way around a circle, what angle do I get? And you can't answer because you already know. Yeah. 360, that's correct. Okay, what if my robot turns in the other direction and it only goes a quarter of a turn around? What angle do you think that would be? Okay, if I start like this and I turn in the other direction for a quarter rotation, yeah, it's 90 degrees. If I went this way, it'd be positive 90 degrees. And if I go this way, it's negative 90 degrees. So we're actually going to control our robot's direction by paying attention to what that angle is and what we want that angle to be. For example, if I started with my robot right here on the mat, can you guys see? Okay. And the robot is currently facing that way when I launch my program, but I actually want my robot to drive in that direction. I would first ask the robot to turn until its angle is the angle I care about, and then the robot will drive straight in that direction. Okay? The move blocks that you have available, they don't actually control angles like that. They just control how much the wheels move. So we're going to use the gyro sensor to control how much we want the wheels to move in order to get it to turn into the right direction. Okay, questions about what we're trying to accomplish today? You guys are good? Okay, so let's go ahead and get started. Everybody has a handout, I hope, with the programs on it. I'm also going to, I guess if I'm on here, my screen went blank, didn't it? That was my fault. I also have up here, if I can type the password correctly, one more time. Okay. Woo. Okay. So the first program I want to look at is showing on my screen, and it's about to be on your screens as well. Is that my fault for letting it go to sleep? All right. Hey, thank you for fixing that for us. Okay. The idea is we want to use the gyro sensor, and before we even control our robot, we're going to use the gyro sensor in order to just see what the angle is. And we'll basically use your robot as a compass. You'll be able to run a program and turn your robot and see what direction it's facing. Okay? And that's what this program does. Can everybody see it okay? So I want to jump right here in the middle of the program and talk about some of the blocks, and then we'll go out to what the whole program does. So you see that yellow block there, and it has a picture on it that looks like the gyro sensor that you have attached to your robot. You can find it down here in the yellow section of all of the sensors, I believe. Is that the one right there? The gyro sensor, and drag it up. You'll notice that mine has a 2 up here, and that's because my gyro is plugged into port number 2 on my robot. It doesn't matter which port you plug it into, it's just got to match. The program and the actual wire have to match. And then I went to this block and I configured it to measure an angle. And that's what it's set up to do, and you can tell kind of by looking at that picture that that's measuring an angle. I take the output from that, so it's measuring that angle 0 through 360, or maybe negative numbers depending upon which direction I spun my robot, and feed it into this text box, which then goes into a display. So I should actually see on my screen angle, and then whatever the actual angle is that's coming from the gyro sensor. This is in a loop, so it'll repeat forever. Okay? Now, if we had a couple of hours, I'd have you go ahead and type this into your robots, and program it into your robots. You've got the program in front of you, so you can put it in later. But in the meantime, would you pass my robot around and see what my robot says as you spin it? You guys look at it for a minute and then hand it to the next table, okay? And you can go ahead and turn the robot around and see how the angle changes.
Is it on this one?
No. Okay. While that's passing around, oh, thank you, Carrie. While that's passing around, there's a little bit of code that I put right here before we started displaying the angle. In the middle of that, can you see the gyro sensor block? That gyro sensor block has a reset configuration. That will take whatever direction the robot's currently facing and make that be 0, just in case it wasn't set to be facing at 0 right now. So reset just resets the angle it's facing to count as 0 right now. So any angle after that is how far it's turned from where it was the last time you did the reset command. So. Okay. You guys seeing how that works over there? Okay. Okay. Sweet. Thanks, guys. All right. So what I'm trying to do is get you to understand the way that the gyro sensor works. It just gives us a number, right? That tells us what direction the robot's facing. Now, in the next page of your handout is another program. This is the Calibrate Gyro program, where what I'm going to tell you about it today, I'm not going to go through the details of it, but sometimes when you turn your robot on, you're pushing the power button probably, right? And so if you're pushing the power button and letting go of it, what happens to your robot? Is it still? If you are tapping the power button, is your robot still? especially if you're being aggressive like I am? Or is it bouncing a little bit? It's bouncing a little bit. Well, the gyro sensor detects movement. If your robot is bouncing when it first turns on, then the gyro sensor wasn't still, but the robot doesn't know what still means. And so the robot will actually, the gyro sensor's readings will be off and they won't work correctly. That will happen in a lot of different ways. Sometimes somebody's bumping the robot or bumping the table the robot's on when it gets turned on. There's lots of different ways for the robot gyro to get messed up. And when it gets messed up, what you'll see is that angle, when the robot's just sitting still, instead of the angle staying, the angle number will keep changing even though the robot's not moving. So if that happens to your robot, you need a program like this one that we have here that will, you can run without turning your robot off and on again, and it will just reset the gyro sensor so it knows what 0 means again and what means to be still. Okay? That's in your packet. And hopefully your robot doesn't experience that today. If it does, we'll work our way around it. Okay? So it's an important thing to know if you're going to use the gyro sensor. Okay, I'm going to move to the next program in our list unless there were questions. So are you telling me that I'm so clear that nobody has questions, or you're just bashful?
Maybe we just don't know enough to ask.
Okay. Our last clinic where we did color sensor steering, we had a program like the one that you're looking at here. And this program doesn't do anything fancy. It just uses the Move steering block, which is available down in the green section, Move steering. And it configures it to move the tires just a couple of rotations at a time at a low power. But each one of them uses a different steering number. And the purpose of this program was to experience that if you have 0 for steering, the robot drives straight. If you have a small number for steering, like 20, it'll turn a little bit. If you have a big number for steering, like 50 or 100, your robot will turn a lot. If you have negative numbers, your steering will turn the opposite direction than if you have positive numbers. Okay? Does everybody remember that from our last clinic? Or should we go over it again some more? It's just that the steering number chooses the direction the robot goes in. Okay, we're good? Okay, so we're going to move to the next step, which is we actually want to have the robot steer based off of what direction it is in order to get it to go in the direction we want it to go. And this program isn't actually moving the robot. This program just shows you a little bit of math. Okay? And can we pass this around again? We'll go in the opposite direction this time. You'll see 3 numbers in there when you're looking at that program. The first number is the angle again, the same as we did before. So if you turn the robot left or right, that angle should go up or down. The second number is the angle with 30 subtracted from it. So think of if I wanted my robot to go in the direction of angle 30. So I wanted to turn 30 degrees. That's actually negative 30. I want it to turn 30 degrees before it drives. Then I want the angle to always be 30. And so if I subtract 30 from it, if my angle is actually bigger than 30, I'll have a positive number. And if my actual angle of my robot is less than 30, I'll have a negative number coming out of that subtraction. And that way I can use the positive or negative number to help steer my robot to get it to turn back to its driving at the direction of 30 degrees. The third number that's displayed there is multiplied by 5 in order to make sure that if I'm off even by 1 degree, at least I will do a steering of at least 5, so I actually do an aggressive enough steer, sharp enough steering to get back to the angle I want to be at. So if you were actually using these numbers in a program, you would change the 30 and the 5. You change the 30 to be the angle you want to go at, and the 5 would be how sharply you want your robot to turn. A bigger number means sharper turns, and a smaller number means less sharp turns. Okay, is the robot making its way around? Cool. Now, we're going to get to a program I actually want you to put into your robots. Thank you for your patience in letting me get this far. So this is, I believe, the next page in your handout, so you have a copy up close to look at. But I'll put it on the screen here as well. Okay, those blue blocks that you're seeing there, in case you don't use those normally, those don't do anything. They're called comment blocks. They're a place for you to type notes into your program so that you can remember what you were trying to do at that part of your program. So what the task is you're trying to accomplish, okay? So this program, it has a loop. What do loops do? What is the purpose of a loop? Yes. To repeat. I want to repeat something, right? I want to do it again and again and again. Okay, excellent. Inside the loop, what are we doing with the gyro sensor? Anybody know what we're doing with the gyro sensor at the first part of that loop? Yes, Taft? Measuring the angle. Okay, excellent. Now this math block, what are we doing again with the math block here? Does anybody know what we're doing with that math block? Subtracting 30 from the angle. Okay? That means I'm trying to get my robot to drive at 30 degrees. The angle I want it to drive at is 30 degrees from where I started it at. Okay? And then I'm taking that number that has 30 degrees subtracted from it, and what am I doing in the next math block? Multiply it by 5. So even if my robot is only 2 degrees off, let's say it's driving at 32 degrees instead of 30, the steering number is going to be 10. Okay? And then I'm taking that result of that math block and feeding it into my move steering block. And the move steering block is driving at what power? In this particular example? Yes?
25.
Excellent. This is 25. And what direction is it steering in?
Straight.
Straight? Why are you saying straight? Because of the arrow?
Yeah.
Okay, good guess. Not right, though. What is the number? What is the number it's using? It's hopefully driving mostly straight, right? 30. We want it to drive at direction 30, but that's not necessarily the number that's coming into there. The number is coming from this math block, right? So let's say that I want to be driving at 30, and my robot is currently in direction 35. So 35 minus 30 is 5. 5 times 5 is 25. So my robot would be steering at 25 as the steering. But as it starts to correct, that 25 would make it turn a little bit, right? As it turns, the 35 angle he's at would go to 34, and then to 33, and eventually to get down to 30, and then he would be going straight again, right, Taft?
Right.
Okay. Cool. Is my robot here? So I'm going to start with my robot just facing straight on the table, and then I'm going to run this program, and it's, remember, trying to drive at the direction of 30 degrees. Can you watch what it does? See how it turned to 30 degrees and then just started driving? And it's going to try to drive in this direction. If I pick it up and set it down like this, what will it do? It wants to drive at 30 degrees. If I set it down like this, what will it do? It'll correct itself and try to go back to 30 degrees before driving. If it's driving and I kick it, what does it do? It goes back to 30 degrees. If I'm driving and it comes along on the map and something bumps into it, oops, it goes back to 30 degrees when it can move forward, right? So this is a very valuable tool for a robot to be able to know what direction it's driving in and correct itself in case it gets bumped or knocked around in some way. Okay? Okay, I want you to have that program in your robot. So can we take a few minutes and go ahead and program that in and let you come and run it up here? I'll try to clear some of my junk out. We've got the home edition. There's like a educational version and a home version. And the educational one has more sensors and things. And so it's the difference between like the hobby kit and the educational kit. Okay. Everybody's putting those programs in right now, right? I'm going to be right back. I'll go grab another computer for you guys to be able to use tonight. Okay. Hey guys. You carry two. And you also don't have the gyro sensor down there? Okay, so you have the home edition of the EV3 software. The educational version has more stuff in it. Okay. Carrie went to grab a couple of computers that will have that. Okay. I believe both are free.
Oh, I'm back to the page one here, but so how do you get that thing to show up? It's not
Oh, up here in that where it says where it has the Mindstorms, this is like a text box for what to display. If you click that, you can say I want it to be wired. See how that? If you say wired instead of a verb or a word, then it will take that. Cool. So you guys need a cable as well. Is that okay if I take this cable? Cool.
as long as they let me borrow that one.
Thank you. So can I download the educational version?
You should be able to. If you want to use this computer for today, thank you. Do you guys want to use this computer for now? The password is CAMPS, C-A-M-P-S.
Yeah, I did I know it because I was.
Because you've done a camp.
Yeah.
Awesome. Camps. Oh, the username should also be camps. How do we go to another user? There it is. Not secure.
Is that A plus B? There's no, is that A plus B equals? A plus B equals? Is that a
This is
plus?
no. This is A minus.
Oh, minus, that's
B.
what this is. Okay, and this is times.
A times B.
Got it. Thank
Cool.
you.
You're doing great. You guys doing good? Okay, do you know your drive motors? Are they B and C? Because this says B and D here.
Why is it different?
B and C is the standard configuration, but that doesn't necessarily mean that's what the... Okay, all right, good deal. Okay, you can make, just make a dummy program really quick, okay?
What's that?
Just make another program where it's not going to have any purpose other than to test your robot. Okay? So let's do move steering, and just put in a bunch of rotations, and then run that and see if both wheels move or not. We can tell you about a world's competition sometime.
Stuff like that.
Yeah.
B and
D.
D
There you go.
program.
We had one motor that wouldn't turn backwards. And
Is it programming? Hold on.
Okay. So both motors are moving straight, right? So it is something with the way you're using the gyro then. That's what we might take on that. Hey guys. Oh no. I'm sorry. You've been waiting for that? Okay, so we're going to search for it, and is that it right there?
Yeah, and what it does is it just takes us. It looks like it has the home one, but not the.
Really? Are you kidding me? Is it did we install the home version and I just haven't figured that out yet? New project, new program, and come down here to sensors.
Yeah, it is not.
This one doesn't, this has the home edition, not the, so can we grab from the teens? The teens and 20 box. Okay. She's going to grab a different computer out of a different box that we think has the right software. Sorry, guys. You're being very patient. How quick are you at clicking? Pretty quick? Once we get you a computer that works, you'll be able to put that in, I hope. Did we find any? Did we find it?
We're just turning it off and turning it back on. We're going to see if that.
Okay. Okay. How you guys doing?
Good. I'm finishing now. We're putting it onto.
Put it on and see if it works? Okay. Excellent.
This is the sender.
Can you show me your program? Measure angle, subtract 30, multiply by 5, steer. Okay, that looks good. And this one here is a reset. So that should make the current direction be 0. Okay. That's all.
That program already resets it every time.
It resets so that the whatever direction it's currently facing is 0. Okay, when this doesn't work, think I know what the issue is, okay? And I should probably talk about it out loud.
Okay, maybe good.
Okay. Yes, same password. Yeah. These guys right here? No. Just two. I'm sorry. I'm sorry. Okay, what was your team name again?
What's our team name? The Unbelegables.
Unbelegables?
Like unbelievable.
Unbelievable Legos. Unbelegables. Okay. Okay. I know we're having a rough time getting started. A couple of guys, you had the home edition of the software. So we've got you, hopefully these computers will work for you now. And so for anybody who watches this later, the home edition of the EV3 software is for the hobby kit, and it doesn't come with, say, a gyro sensor in it, and it doesn't actually allow you to configure the gyro sensor. So the educational edition has gyro sensor and other functionality in it. I believe both are free to download from Lego Education, so it shouldn't, should be able to get it. Okay, another issue that we're running into, can the Unbelegables, can you show us what your robot does with this program? Okay, they put their program in exactly the way I showed it. And what is the robot doing, do you think? Is yours doing the same thing?
But slower.
But more slowly, okay. Okay, cool. So here's one of the things. We're controlling two motors with the gyro direction, right? And we're putting in a number that says if the angle I'm at is bigger than the angle I want, turn to a positive direction. And if the angle I'm at is less than the angle I want it to be, turn in a negative direction. Well, sometimes the way that your two drive motors are wired, yours are probably wired different than mine. Like yours are probably wired normal and mine are probably crossed, right? And because of that, a positive steer number for you moves in the different direction than a positive steer number for me. You can quickly solve that problem by going to this 5 that you're multiplying by and make it a -5 instead of a +5. That will change the direction you turn when you're over or under the angle.
Which slide was that?
It's right here when you're multiplying to say how sharp to turn. Just make that a negative number instead of a positive number, and then see if that actually fixes it. That should, okay? And you guys that are still typing your program in, I'm sorry for the delays there. Oh! You guys want to come up here and run it? Where you have a little more space, you don't have to worry about at least falling off. Perfect. Okay, if you want to step up your challenge a little bit. So your robot was driving in this direction, right? I want you to make it drive in that direction now. Change your program just a little bit so it drives in that direction instead. Okay? Are you guys able to find everything or not yet? Oh, I'm so sorry. It's not optimized. Oh my goodness. Really? I guess we can. Okay is all we can say, right?
I think that's it.
We'll just do it. Sorry about this. No, later it's. Okay, let's go full screen. Is it? Let's make a new project for you.
And then we have to plug it into ours, right?
Let that go. New project, programming project. All right, cool. Hopefully, let's just double check. Yeah, gyro sensor's down here. Okay, you should be good to go now. Sorry for the delays.
We got it this way.
Okay. Cool. Can you show me up there? All right.
Should I start it when I...
Yeah, go ahead and run it when you get up there, yeah. So if you want to speed up today, you don't have to type the comments in, the blue ones. Those are just for notes. They don't actually do anything. So you'll be faster if you don't type those in. But you can put them in if you want. I use them because I forget what I did when I was in a program. When I come back to the program, I want to read. Remember, this is what you were doing here. So that's why they're there. Okay, is yours guys working now the way you wanted it to?
It's just, we upped the speed on the power and the power on it, but it's still going the same. One is up. It's supposed to do that. It's looking for a certain angle, I think. Oh yeah.
Okay, and you changed it to a negative number and it's still doing the same drive that it did before? Okay.
Change this one?
No, you changed the correct one. Okay, let me ask you this. This says that we're trying to use the B and C motors. Is that what you're plugged into here?
Yep. We're in B. Yes?
We're plugged into B and C. That's good. You know, your power in this program is set to 50.
Yes. We just changed it.
Did you download the 50? No, go ahead and leave the 50 in. That's fine
Yeah, we
for now.
downloaded it.
You downloaded it with the 50 and it's still driving that slowly?
Yeah, before it was driving way slower. Before
It was even slower before that?
Yeah, before it was just going like this.
Wow. Because with 50, I would expect the motors to be really moving fast. Like at half, that's half power. That's really fast. It should be.
So what is the...
So your program is called Kitten.
Yes. Yes.
And it's in the Stallion bots.
Yes.
Can I look at your screen?
Yeah.
Thank you.
Oh wait. I just want to. She just like.
Stallion bots kitten.
Yeah. It just goes into circles. Wait, is it going faster? Maybe you pick the wrong kitten. No, because there's one kitten. I think it's trying to find the angle, and when he holds it up, there's no angle to find. No, there's always an angle. It can't measure air. Oh yeah, that's true. But like this, it can't.
Does this one work correctly?
I think, yeah, I think this one. That one works correctly.
Guess what, guys? I see something. Look at these two connectors. Can you see those two connectors that are plugged into the robot?
Yeah.
What's different about the way they're plugged in?
One's too close.
Click. One of your motors wasn't plugged in all the way.
Oh, try it now.
Try it now.
Okay, try it. It works.
Okay, so your 50 power is definitely 50.
This one do that. This one do that.
That's funny.
Okay, I think what I did might have messed up your gyro though. So I think we should probably turn this robot off and turn it on again, okay?
Okay.
Sorry about that. We want to make sure that when you turn it on, make sure the table's really still when you turn it on, okay?
Okay,
Yeah.
one. Not the table. This one starts.
Do you guys want some help getting it in?
We got the education.
Oh, you did? So you got your own version working?
Yeah.
Good job. So I'll just get rid of this, get this out of your way then.
Yeah.
Sweet. Good job. You guys messing with it now? Yeah. Okay, cool. You keep. Cool. Way to go, guys. Did you get the internet? These guys actually were able to download the education version, so.
So mine actually works. So no, otherwise, like stop the
This is
program.
right here, right there.
Oh, that thing.
Yeah, that's the cancel button.
So how do I rename these names?
Okay, if you double click on them, on the where the word is, the name, then it's an editable field. Don't ask me. Yeah.
I'm sure I tried that, but of course I did.
Well, don't ask me if I don't think that's a great user interface, but. Are you sure that's the program? That doesn't look like the program. That looks like a different program. Can I see over here? Oh, okay. You need to make this be an on right here.
On.
Okay, you'll be happier with that. Yes.
Why did yours go in circles?
Maybe one of
Now, is it, okay, that robot that is working and this one that is not working. What I want you to do on both of them is follow, I want you to follow the B wire. Does the B wire here go to the left side or the right side? And what does the B wire go to on your robot, the left side or the right?
Ours goes to, yeah, B goes to left.
Your B goes to the left and your B goes to the right. Switch your B and C,
Yeah.
and then it will be wired the same way that one is.
Wait,
Yeah, that's right. That's right.
right.
I'll hold this one while you pull the other one out, okay? And then that one was C, so put it back in B. Okay, and then plug this one in C. Are you at 100% power?
Yes, he turned it to 100. Million, actually.
Yep, something's wrong. That or our robot's going mad.
Can I pick it up?
Yeah.
Keep it for a little bit and then it will go straight in. Wiggle, wiggle.
B and C are in.
There you go. Stop.
Okay. What I want you to do, it's possible that your gyro sensor itself is like drifting. So let's try to stop it and maybe turn your robot off and turn it back on again. But when you turn it on, make sure the robot's completely still, its table isn't bumping or anything like that.
Yeah.
Okay? So that waddle is because your power is so high.
I know. No, look. I turn it this way and it turns that way.
And it's slowly drifting. Okay, it's your gyro sensor is a little off still. Remember we shut it down and turned it back on? That didn't heal it for whatever reason.
I think it's because my speed was like maximum.
So that was part of what you're seeing, but the fact that it's trying to drive in this direction and then later it's trying to drive in this direction, later it's trying to drive in this direction, the gyro sensor is drifting.
Okay,
Okay.
so how do we set the gyro sensor back to?
To make it stop drifting, that's what this calibrate program is that I was hoping we wouldn't need today. Where is it? Yes, this one here.
This is the calibration program?
That will reset it, like it'll reset the gyro so that it knows what still means. Good. Now if we don't bump the table at all,
Don't bump it, Grace.
I'm going to turn it back on, okay?
It only does that just to begin with, and then it straightens out.
Yeah, that's
We'll wait till it finishes booting so that if it doesn't shake at all during this, it should be better. Should be.
no one touch the table.
And back away from the table.
You're still drifting some?
Got the circle program going.
So,
I think it's because before my,
huh?
because there's,
So, but what can happen is that gyro sensor itself starts to drift because it doesn't know what still means. And did you restart your robot? So if you restart it when it's sitting completely still, then it has a better chance of knowing what still means. Otherwise, you have to get this program and run this program after it starts. Okay? So a lot of teams will do that. They'll have the program like this, and they'll take the robot up to the table, set it still on the table, and run this program before they actually start competing. So basically,
okay.
yeah, during that 1 minute, you have a lot of setup things you can do. This is one of them.
Don't bump the table.
Okay. Is yours, guys, is it working? Check it out. Okay, so how would you modify it so that if it starts here, it'll drive in that direction instead?
That's cool. Wait, no.
Okay, I want to see it, all right? So we're just having fun with the gyro. I hope we get to see a lot more teams using the gyro and color sensor this year. So, what time does your thing start here? And that's virtual reality. Okay. Cool. Oh, hey, you guys did it. You made it go faster too? Way to go. Isn't that pretty cool? I mean, whatever direction it's in, it'll just spin till it gets to the right place. Way to go.
I'm going to try for 30.
What time are we supposed to finish?
6:30, but they can finish.
Because I have one more thing I'd like to do, but I want to make sure this one was solid before I... 15 minutes? Okay. How do you guys feel? Is it working all right? You're able to make it drive whatever direction you want now? Okay, we're feeling good? All right? Cool. Is it behaving better now, guys?
Yeah.
Okay, cool. Are you okay if we move on to another task?
I downloaded this new version of it, but it doesn't look like it's right. It's not giving me those same options.
That looks completely different, doesn't it? I mean, like it's a whole new different set of icons and everything. Theirs looked normal.
I mean, I'll just take it
Okay.
off and read.
Okay. Okay. If we move on to another task, are you guys okay? Okay. You guys okay if we move on to a new task?
Yeah.
Okay. All right, everybody. I hope you've been having fun, enjoying making the robot drive in the direction you want it to drive. And I think everybody's made changes. Has everybody changed the 30 number to something else to make your robot drive in a different direction? Okay? So all you have to do if you want the robot to drive in a direction, you just give it the number there, and then the robot drives in that direction. Now, there's another really good task for the gyro sensor. And this task is not driving, but just turning. So if my robot, for example, was sitting right here, and I wanted it to go operate on that house model over there on the field, then what direction do I want it to turn to? I want it to turn to the left 90 degrees, right? So if I want the robot to turn to the left 90 degrees, I would like not to say, how many rotations is that? But that's what we've been doing, right? Say, turn so many rotations to get it to move. We want it to instead say, take the angle that the robot's at currently and keep turning until the angle is 90 degrees less than the angle it's currently at. Okay? And that will be a more precise turn. So, for example, if I run this program, that's what my robot does, and it stops at 90 degrees. I don't have to measure the rotations and then run it and say, oh, that was wrong, and change my rotations. Instead, I can just say, that's the angle I want, and let the robot figure it out by watching the gyro sensor. Okay, it's a more precise way to turn than what we normally do. Okay, the other way is good, this is better. So, in your packets, there should be a program that looks like this. I'm going to zoom in for you. Okay. So really, this program is a lot simpler than the one you just did. The main part of it is this loop right here. If you look at that loop, you can see that it is going to stop when the gyro sensor reads a number that's either less than or equal to -90. Right? Okay, does less than or equal to in the math you do in school, is that you understand what less than or equal to means? Okay, so is negative 100 less than or equal to negative 90? Negative 100 less than or equal to negative 90. Negative numbers are tough? Okay. It is less than because negative is less than as you keep going more and more negative. So negative 2 is less than negative 1. Negative 3 is less than negative 2. Negative 100 is less than negative 90. Let me ask you this. Is negative 90 less than 0? Yes, it is. What about positive 90? Is it less than 0? No? Okay. So what we're going to do is start with our robot at an angle that it thinks is 0, and that's what this block does. It sets the current angle to 0, and then it says wait until the angle is less than or equal to negative 90. So it's going to count down. It'll be 0, negative 1, negative 2, negative 3, negative 50, negative 60, 80, 90. Negative 90, it'll stop turning. Okay? So all that loop does is keep turning slowly to the left until we reach negative 90. Then the loop stops, and we do this move steering block here, which turns the motors off, so it stops turning. Okay? Everything else there is just like cutesy stuff. Okay? The loop is the important part. Turn until we reach negative 90. Okay? Now, most of you that had to put a negative 5 in, who had to put a negative 5 instead of a positive 5? You guys here? You guys here? Like everybody but me? Okay, fine. That means when you put in this move steering block here, you want a negative 100 instead of a positive 100 for your steering. Okay? So I apologize for that. Okay, so what I would like for you to do then, in the time that we have left, is put this program in. The comments you don't have to put in. Those are just for helping us understand what's going on. But if you're in a hurry, you don't need to put the comments in. You can add them later. And this whole stop things down here is, again, just nice to tell the user we're done. We don't really care about that. I care about the reset, followed by the loop with the drive block and the stop condition, and then stopping with the drive block after. And then get it to turn to negative 90 and then change it. Can you make it turn to negative 180, for example? Okay? All right. I so loved Into Orbit. It was so fun. I'd like to go to the moon someday, but I probably won't make it. They're very, very literal. They're putting the comments in anyway, which is great.
That's all right.
So.
Too bad it's not our own computer.
If it was your own computer, it'd be more valuable, right?
Yeah.
I guess if you had a flash drive, you could download the program from here, take them and put them in your computer. Hey, do we have any gimme flash drives with us? I didn't bring any, did you? Okay, you know what? Let me check, maybe I do have some. They have the paper. They can type them in again. They have the paper, so they can re-enter the programs. No, I didn't think about it till now. Just because I thought they had their own. If they had their own laptops, they wouldn't have needed to. Right? Because they would have had the code in their laptop already. It's all good. No, I do not. Thank you. Thank you. Did it go 90?
Yep, you're right. Like I was in Paris Sunday, and they were rolling dice to like.
Okay. So did you guys have to put in a -5 to make your robot drive straight? Then did you change this to be -100? If you take, because so what yours is driving in the positive direction, so it keeps increasing its angle. It's never decreasing its angle back to -90.
How it just spins.
Yeah.
Forward on those. It still did it.
Oh, you guys Bluetoothed up? Okay. Oh, cool. Doing it? Oh, yes. Very good.
Make it go faster now.
Okay, you try to speed it up. Try to get it to do a different. Can you get it to go like so it turns all the way around and does 180?
Right. Goes all the way around and then lands right there.
No, it starts like this and it ends up facing this direction instead.
So it goes all the way.
Like that. Uh-huh. How's it looking, guys? You got your program working?
Ian, go. We're trying to. I need him to change it to this. I can. You know how to do that? Change it to this. Not
Okay, so it's through this right here. Click on where it has that circle with a pound sign in the middle. Uh-huh. Say off. So this one turns the motors on, and this one turns the motors off after you've reached the location you wanted to reach.
So now we need to go.
And did you guys do -5? Okay, then this needs to be -100 instead of positive
Oh, wait, no,
100.
we did positive.
No, in the previous program, did you have to multiply by -5 or +5?
Negative.
-5?
Yeah.
Then you just need to change this 100 right here to -100. This is supposed to stay,
Positive?
yeah. This is supposed to be, yeah, less than or equal to still. Yep.
Okay, so
Just,
negative.
and you can drag that bar all the way over to the left. Oh, or you're faster. You're typing it. Awesome.
So,
That should do it.
so we don't need these little things. Wait, we still need these.
You don't need these.
No?
You don't need these. That's enough. That is sufficient. Okay. If you click this green button, you'll have a bigger screen.
Oh, yeah,
There you go. How's it looking, guys?
We got ours ready, but we just need it down. No, that's not
It did work.
There we go. We got the 180.
Cool. Why do you think it goes over? Okay, so he's spinning super fast, right? And he keeps checking the gyro sensor, but by the time he checks it and finds out that it's more than it's past -180, he's gone a lot past -180 because he's going so fast. If he turns more slowly, then he can check more frequently, and so he'll be able to see more precisely. So you kind of adjust it between those two until you get what you want. Are you guys going to climb up the ramp this year?
I want to try it.
Is that why you put the ski on?
We actually used this last year.
Did you? Oh, uh-huh.
Because whenever we had the ball, it would just get stuck. Yeah.
So to drive over the craters?
Yeah.
Oh, cool, cool.
We got ours ready.
Oh, you want to show me?
Oh. There.
Cool. Sweet. Good job. So now you can put these things together to get your robot to do more complicated driving, but do it precisely, right? Do it accurately. That's awesome. So, cool. Are we hitting 6:30?
So we figured that 50 was
50 is better? So, guys, mine's driving at 10. But that means I'm going to take a long time to turn, right?
Yeah, it's gonna be like.
Yeah.
With this little fabric, it makes it.
Oh, this fabric is different than the mats these days, right? It's a lot catchier. Okay.
Is this the new? Is this?
This is old. This is like 4, 5, 6 years ago, maybe.
Is this like a hurricane or something?
It was called Nature's Fury. This is several years ago.
I'm gonna say, this is not the map.
No, this is not this year. That's right. They get stick on some of the dual lock. Do it over here, so. Okay, guys. How's it looking over here at this table? We good? How about over here at this table? You guys good? Don't know if it's doing what it's supposed to. Can you show me what it does?
Did it turn?
How do you feel about that? That's not very satisfying, is it?
No.
All right. I'm with you. So that's this program right here?
Well, that's good.
It immediately ends.
Well,
The error could have been if you didn't
if
allow
you look
access.
really closely, it moves it would move a tiny little bit.
Yeah, so now you can come up.
And your gyro sensor is number 1. Okay. Gyro sensor compare angle. That's good. Stop. Gyro sensor reset.
Yeah, how do you download?
Okay. Are you still connected? Can you just connect it back up again?
Where it becomes the
Okay. You have 2 gyro sensors.
We're not using this.
Okay.
Where do you want me to put it?
Just right there is fine.
we have two?
This says you have 2.
We don't have two. We have a color sensor, a gyro sensor, and just 2 modems.
You have 3 sensors plugged in. That's ultrasonic.
That's ultrasonic.
That's this one.
This is one. Yeah, it's
That's
not showing up with
that's supposed to be a color sensor, isn't it?
Yeah.
Weird.
On port 2, yeah, it's supposed to.
That's weird that it's showing it that way. Okay, well, you are trying to use number 1 here. Oh, look, see there? Boom, that's the issue. You ready? I'm just going to run it from here. Catch it if it falls off. That's it. Okay. I'm not sure why that's reading the color sensor as if it was a gyro. If that continues, then you might unplug and replug and reboot it or something, okay?
How do we
Okay.
download stuff onto a flash drive so we can put it into that?
Perfect. All right, let's do this. So first off, we want to come up here and save project. Give your project a name right there. Okay. I'll help you transfer that in just a second, okay? All right, everybody. I think it's time for us to wrap up today. I hope everybody had a great time, learned something today. If you want, you can take the packet of handouts and you see the program I have here. This doesn't actually do anything. It's just a recommendation. Can you get your robot to do something such as drive at angle 0 for a while, turn left 90 degrees, and then drive straight at negative 90 degrees for a while. Can you get your robot to do more complicated behaviors now in one program? Can you string these things together to get it to accomplish a larger task? Because now you can make it do the small task, stick them together so you can make it do a larger task. Okay? I hope that this has been useful for you and that you will use this as you build your missions for this LEGO League season and future seasons.